Ladies and gentlemen, please welcome co-founder and CEO, NVIDIA, Jen-Hsun Huang.
NVIDIA builds computing technologies for the most demanding computer users in the world. We build it for you. Your work is done at such a gigantic scale. Your work so amazing, stakes so high, impact so great. Because your work has to be done within your lifetime. The computers you need are not the run-of-the-mill computers. You need a supercharged form of computing. We call it GPU accelerated computing. The GPU has become an essential instrument of your science, of your art, of your discoveries. And we think that the work you do are so amazing that we believe it's going to change the world. So we've dedicated our company to a singular craft. We've dedicated ourselves to advance the field that we're in a way that no company ever has. We want to do our work so well so that you could do your work, so that you can do amazing things and change the world. GTC is about GPU computing. GTC is where the early adopters of GPU computing come to share your discoveries, to reveal your innovations, to tell the world what amazing work you've done. GTC is getting bigger than ever, and it's accelerating. This year's GTC is twice as large as the GTC when we revealed Kepler in 2012. Now, the amazing thing is this. This is just a US GTC. Since 2012, we now do GTCs around the world. There's a GTC in Japan, which is coming up. We expect several thousand attendees to that. There's a GTC in Europe that will be starting this year. There's small GTCs happening all over the world. And yet, here in the United States, it's doubled in the last 4 years. The industries that come are broad and wide-ranging. And because of all the attendees, there are so many developers around the world now. In just 4 years' time, the number of developers of CUDA has increased by a factor of 4. But what's really amazing is this. Of the 300,000 CUDA developers in the world, the two that has grown the fastest, internet, hyperscale, and the automotive industry, hyperscale, internet, and auto, has increased by a factor of 10. There are now 300,000 developers around the world. And as a result, the number of high-performance computers that include GPUs is also growing incredibly fast. Supercomputing, high-performance computing, has doubled in just 2 years' time, from 2013 to 2015. In fact, 97% of all new high-performance computers, all new supercomputers, include NVIDIA's technology. I want to thank all of you for the support. I want to thank all of you for believing in NVIDIA. I want to thank all of you for adopting GPUs to do your work. Thank you very much. This is going to be the best GTC ever. And so let's get started. Today I'm going to talk about 5 things. First, I'm going to talk about a toolkit. Then I'm going to talk about VR. And then we're going to talk about deep learning, a deep learning chip, a deep learning box, and a deep learning car. We're going to talk a lot about deep learning, so let's get started. Today I'm excited to announce the NVIDIA SDK. This is a unified toolkit, a unified SDK. The essential tools necessary, the essential libraries necessary for anybody who is doing GPU computing development. You know that one of the most important things we do in our company Building chips, of course, is one of them. Designing systems is another. Developing system software is very important to us. But one of our greatest investments, and one that I'm incredibly proud of, is the computational mathematicians in our company who are domain experts in their field, who are also experts in how GPUs work. That intersection between computational sciences and GPU architecture allows us to create new algorithms that are now embodied in libraries so that developers of all industries can take advantage of these tools to accelerate, to enhance, to make easy their work. There are so many different types of libraries in the NVIDIA SDK. Let me quickly go through some of them for you. The first one, of course, is the NVIDIA GameWorks. We love games, and we love graphics. Games and graphics has really pushed the boundaries of advanced computing for many, many years. For nearly 25 years, we've seen how quickly computer games has evolved and how hard it pushes technology. In fact, when I met Demis recently, and we were both talking at New York University, he came up to me and he said, "Hey, I'm a gamer," and he introduced himself. Demis introduced himself to me, not as an artificial intelligence research expert, but as a game developer. And he says he's known about our GPUs his whole life. And he's been a game developer and a gamer his whole life. And that's kind of how we started our relationship. GameWorks, amazing library, has physics, simulating the world is, of course, very, very important in the beginning of suspending you in disbelief. Creating a realistic world is the beginning of great games. Physics is an important part of it, simulating hair, simulating water, simulating fire, simulating smoke, so that when you're in this environment, you feel that it's behaving in a real way. We got all kinds of new technologies that are now involved in GameWorks you can download pretty soon. Volumetric lighting, voxel accelerated ambient occlusion, those little creases, nooks and crannies in the geometries that you see around, all around you, with the little tiny shadows, that subtlety creates depth and it creates the nuance that convinces us what we're looking at is real. Trace shadows, hyperfresh from trace shadows, so that the shadows are softer as it goes further away from where you are. Okay, all of that's available now. NVIDIA DesignWorks. GameWorks is to make real-time graphics realistic. What DesignWorks is all about is making photoreal graphics. iRay is our physically simulated ray tracing system. It creates basically photorealistic images from computer designs. It is so vital in this particular field for us not just to create something that looks beautiful, but it has to be accurate, physically simulated so that what's rendered is what you're actually going to see. What you render is what you see. We have a new library called MDL, it's a material description language, which embodies all of the complex mathematics of how surfaces react in an environment. Carbon fiber looks like carbon fiber, brushed aluminum looks like brushed aluminum, gold looks like gold, and gold paint looks like gold paint. Being able to capture the nuance and the complex mathematics of these materials is vital for us to recreate reality. Optics, not only do we use our own engines for our own ray tracer, like iRay, optics is essentially the cuDNN, if you will, of graphics, of path tracing. This library accelerates path tracers, and we keep it open so that other people could develop their ray tracers on top of it. And then path rendering. When you look at scalable fonts in your text and how it's beautiful no matter what resolution you run it at, illustration has this property. When you zoom into it, it still remains beautiful. Those paths are rendered with computer graphics algorithms, and now we can accelerate it with the GPU. All kinds of new terrific tools that are in DesignWorks. ComputeWorks. CUDA is the computing architecture of our GPU. It is the reason why many of you have come to GTC. It has really revolutionized accelerated computing. It has democratized high-performance computing and made it available to every industry, every developer. CUDA is incredibly important to us. Whoop, I'm looking at the wrong slide. Here, I'll go here first. ComputeWorks. I'll come back to VRWorks and we'll go forward. On top of CUDA is a very important library called cuDNN. It's a deep neural net library. It's a linear algebra library that allows neural net developers to create their frameworks, their neural net architectures on top of our GPUs and have it run as fast as possible. cuDNN is one of the reasons why training networks on our GPUs is 10, 20 times faster than running on CPUs alone. We're also introducing today a graph analytics library. Graph analytics is important in understanding the relationship of data to each other. In a social graphs, for example, who has the most followers? Who's closest to a particular follower? Who's related to whom? What object is related to what other object? Understanding the relationship of data in a very, very large social graph is incredibly important today. Almost every internet company of just about commerce or search or looking at databases, trying to find insight from their database requires graph analytics. We can now accelerate graph analytics quite significantly, and this is going to be a really powerful new tool. Index. Running supercomputing simulations generates terabytes and terabytes of data. You now have to take that data and try to find insight from it. There is just simply no way to wade through all of that data on a spreadsheet and try to discover some insight. The only way to do that is to visualize it. And so now we introduce an in situ visualization platform where you could simulate the data, do your simulation, generating huge amounts of data, and in exactly the same supercomputer, render the volumetric image. There's some videos that you can see of a tornado simulation, a rocket combustion simulation. You could see that on the show floor this week. Really excited about that. It's called Index, the world's largest visualization platform, designed to visualize huge amounts of data that's generated from supercomputing simulations. This week, we're announcing that CUDA 8, the next generation of CUDA 8, the next generation CUDA is coming. It supports our new GPU architecture with all of its architectural benefits. cuDNN 5, even faster than cuDNN 4, of course, and supports new features like long-term, short-term memory. NVGraph, as I've mentioned, and then Index. Very quickly, I'll go back to VR. VR is an exciting new platform. And with every new platform, you enjoy graphics, in this particular case, in a very different way. You're suspended in that room, you're suspended in that environment. Because you're seeing the graphics so close to you, and because this graphics is moving with your head and with your body, any latency is going to cause you some amount of sickness. The latency, the performance, the interaction with the actual applications, incredibly important. We've created all kinds of new technologies for this new platform, and we're super delighted that they're integrated into head-mount displays by Oculus Rift, by HTC Vive, and it's also integrated into game engines like Epic, like Max Play and Unity games. Amazing new experience. I'm going to talk a little bit more about that in just a moment. And then DriveWorks. DriveWorks is to our autonomous driving car computer what GameWorks is to GeForce. It's a suite of libraries, algorithms, that allows car developers or car startups or car platform developers to create self-driving cars. It is still in development. I'm going to give you an update today of some exciting things that we're working on, and hopefully announce something new. It's still in development, but they're accessible to some joint project laboratory partners, JPL partners. A handful of partners we're working very, very closely with. We treat them essentially like our own internal engineering team. The work, just like working among ourselves inside the company, is of course rather rough, but it gives them early access and gives them access to the market, time to market advantage of about a year. Early access program partners will be expanded to a larger handful, and we'll reveal that in Q2 of this year. And then general release will be Q1 of next year. We're working really, really hard in this area. Some really exciting developments that I'll share with you in just a moment. Autonomous machines. The smallest of embedded computers, the Jetson little one-chip computer, is the world's first embedded computer with deep learning capability. It has its own SDK and all of its tools because it's architecturally compatible with everything NVIDIA. It's architecturally compatible with all of our suites. The software and the algorithms would work very naturally on this particular platform as well. Jetson is designed for autonomous machines, robots, cars, drones, that will in the future embed artificial intelligence deep learning capability. Today, we're super excited to announce a new library for our platforms. It's called GIE, the GPU Inference Engine. Until now, it's been very clear that our GPUs are incredibly good at training networks. We could rip through images and train those networks with an enormous amount of data. We accelerate training by a factor of 10, by a factor of 20. We could take training runs that used to take weeks and reduce it down to days. However, one of the criticisms of our architecture has been that when it comes to inferencing, which is inferencing, classification, or the production part of the network, our performance is not as high, and the energy efficiency is not as high. Well, we changed all of that. There isn't something inherently counterintuitive relative to our architecture. It's simply we haven't created an engine for it. Where cuDNN is really designed for training, GIE is designed for inferencing. GIE is available today on our GPUs, and as a result, on TX1, Jetson TX1, the inferencing performance has increased from 4 images per second per watt to 24 images per second per watt. 24 images per second per watt is not only the most energy efficient, it's already the highest performance, but it's not only the highest performance, it's also now the most energy efficient. That level of energy efficiency makes CUDA unquestionably the highest performance and the most energy efficient approach to doing deep learning. Jetson TX1, 24 images per second per watt. So in just a little tiny computer, let's say that little tiny computer is 10 watts. 10-watt computer, 24 images per second per watt, gives you a sense of what you could do with inferencing in an embedded machine. Whether you're a robot or a drone, you can now look at images at a very high frame rate, infer information from it, and take the appropriate action. The NVIDIA Jetpack with the GIE available in May.